Hello and welcome to the second session where we are building an adaptive RAG thing. I would suggest you to consider watching the adaptive RAG videos after you have completed the agentic workflows, the entire playlist up to session 9 maybe, so that you can have a hang of LangGraph, and this will fit right in smoothly with your knowledge base. Anyway, in the last session, we kind of built up all the utils kind of required for retriever, the grading, hallucination grading, rewriting, all this stuff, and we understood what we are planning to build and the intuition behind it. Now, in this session, we are going to put all of these fragments together and get it working. So, first of all, this entire workflow that you see here, let me just pull it a little bit to the down. Yeah, cool. So this entire workflow where we have the RAG thing happening, so this gets triggered whenever the router says that yes, the question is related to the index documents in the vector store. Then this entire RAG thing happens, grading and all these feedback, fallback things happen. This complex workflow we will build in LangGraph. But if the question is unrelated to the indexed documents in our vector store, then we will have to follow this particular workflow where it's a simple thing. So we don't need LangGraph for this workflow because it's very simple. We can use a simple chain, a LangChain chain or runnable chain to execute this part. Okay. So first of all, in this video, I'm going to build this part, and then we will build this part, and then we will stitch all of them together and see it working. Okay. So without wasting any time, let's jump right into it. So first of all, I'm building the tool response chain. We know that the tool response chain basically requires a user question, and it will search the web for it, get some information from the web, and then we have to kind of append all of that information from the web into our prompt and let the LLM do the magic. Okay, so just like in retrieval augmented generation, we append the retrieved chunks into the prompt. While using a web search tool, we do something of that sort. We basically append the web search results into the prompt to get response. So first of all, okay, I've imported the Tavily search results tool, and then I've instantiated a web search tool. K equals 3 is basically, you can check it out what it means. So if I write K, it's basically the search results, kind of the top 3, top 5, I mean depends, right? It's kind of a parameter. And then after defining this tool, I binded this tool to an LLM web search equals bind tools. You know how we bind tools. If you don't, you can check out the agentic workflows playlist. I have covered up kind of a lot of things related to tool binding, React agents, all those stuff. Cool. Now this is the prompt template, so it's along the lines of that you are an assistant and you will be provided with a list of web search results. Use those to answer this particular question, and these are the search results. Okay, now we get this prompt and then we define. So this particular function is kind of post processing the search results to basically get them in a string format, which are separated by two enters, two kind of paragraph spaces, and fed into the prompt. Okay, and this is the chain used for the final response. And then we have this particular function, tool call function, which is stitching all of this together. So what the tool call function is doing, first of all, it is triggering. So first of all, it is triggering the LLM binded with tool on the input. And we know that whenever an LLM is binded with a tool, it chooses whether to respond with a tool call or respond with a generic LLM response. So if there is tool calls, so if the LLM chooses to call the web search tool, then print calling Tavily tool and get the search results. This part might seem a bit overwhelming to you, but try it out yourself and you'll see what it all means. Basically it depends on the format in which we receive the output from a Tavily web search. So then we pass these search results to the post-processing function to get them all in a string kind of a format here. So I should write here post-processing the search results, and then I'm printing the search results once so that I can have an understanding of what the LLM is grounding its answers on. And then this is the chain response, which is ingesting the search results to stitch up an answer. Cool. And then this is the response that I want to print. Else, if the I should write if the LLM chooses not to call the web search tool, then it would basically be generating a generic LLM response. In that case, I will print generic LLM response and then print response.content. Let's see how it works. Okay, let's see it working. This might be a little bit long video, so bear with that, but I'm sure you'll be learning a lot. Okay, so our function is called tool call, so I would just be saying tool call, and my input is something like, say I'm writing something very generic. Okay, hi, let's see what it does. So let me get this down here. So it is opting not to call the web search tool, which is pretty obvious. The LLM does not need to call the Tavily web search tool to respond to a simple hi. But what if I ask it something very particular that requires a web search? Say I'm asking it what is capital of Finland. Let's see what it does now. Now it has chosen to call the Tavily tool, searching the web, got all of these results. So this is the kind of format in which we get the results from the Tavily. That's why we require post-processing. And then this is the final response. The capital of Finland is Helsinki, most populous city in the country, blah 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 blah. So it's working, right? It's working. So we got done with this part. We know that if the question is unrelated to the index documents, what should we do? How should we proceed? Now we have to build this big gorilla of a workflow, and that's why we'll be using LangGraph, because doing this using normal chains and if-else statements, it would be a pain in the okay. So up until here I've just written it so that it will be easy for you to follow when you are using the notebook. Up until here we have written code to facilitate the graders, the router. Yeah, I've also instantiated the router thing, which we'll be using later to stitch both of these flows together. Answer grader, web search tool, LLM response, yeah, blah 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 blah. Okay, now we step into building the workflow using LangGraph. So we are defining a state. You must have seen in the agentic workflows playlist we were using the messages state. Well, that was very good for a chatbot, but here I'm trying to build this workflow together, and it requires more than one messages state. So here we have decided to have three keys or three kinds of information in our state. First is the question, the response, and the documents. The question is basically the question which the user is asking. So this particular question key will hold the user question, or it will hold the rewritten question. Whatever question needs to be fed to the LLM will be held in this question key. The response key will hold the LLM response, obviously, and the documents will hold the list of retrieved documents from the vector store. Okay. So here we have defined the graph state. Cool. Execute it. Then we define the retrieve node. Now, for a revision, we had defined a kind of a chain to retrieve documents, which we will be using while defining the graph now, the kind of utils that we created in the last video. Okay. So we know that every single node in a LangGraph workflow is basically a small state machine. It takes in a particular state and returns a particular state, an updated state. So retrieve state basically takes in input an argument. It's taking in input the state, which is this particular state, and it will return by adding a new key to that particular state, which is called as documents. Okay, so it will basically take in input a question. Based on that question, it will retrieve a set of documents, and then it will create this new key documents, which will have a list of retrieved documents. Okay, that's what it's doing, retrieve. So whenever this gets triggered, print retrieval question, we are fetching the question. Basically I should give another enter, right? I'm saying fetch the question from the state, or I should write the current state. So it gets the question because we know that question is stored in the question key, so I'm getting it by state question. And then use doc vector store as retriever to get similar documents. We have defined this retriever earlier. Let me show you. Go to definition. You see we have defined the retriever as a vector store dot as retriever. You can do that. We have chroma as a vector store, so we defined that shit. Where are we now? Oh my god, it has become a little bit longer than I expected it to be. Cool. We took the retriever and got the relevant documents. Now we ingest this list of documents into the document key of the state. So updating the state with documents key, and then I say returning the updated state. Now, for the people who have been following through the Agentic Workflows playlist, you might have noticed that my state class does not have a reducer in it. I'm not using reducers. I am not appending states here. The reason is pretty simple. I'm trying to make this simple, okay? And it's a kind of a knowledge for you as well that we don't need to use reducers all the time, okay? So we don't want to, append messages and all that stuff. We are simply kind of updating a state. We don't care if we lose out on the earlier information because we just are working with the current information in the state that we have. So that's working pretty fine. But yeah, in the future, if we are working, if you want to enable this particular application with a memory feature, then yeah, we might want to think in that direction in the future, okay? But right now, we want to understand how it works. So let's keep it a little bit crisp and conceptual. Cool. And I know you guys are literally very good coders, so feel free to play around, have fun, okay? Response generation node defined. So now we are done with defining the retrieve node. Now we want to go to define this particular node, LLM node. You might be thinking, why are we not defining them in the right order? I mean, I didn't do that, so doesn't matter. The generate node is basically taking in the question and the documents, and then it is invoking the RAG chain that we created in the last video to get the response, and then it updates the state with the response in the response key. That's why we also configure the response key in our graph state. So let me comment it out a little bit better, fetching the question and documents from the current state. Okay, and then we use the rag chain to get the response. This rag chain is basically doing nothing special, just taking in the documents, parsing them, appending them to the prompt, and getting the LLM response. That's it. Okay, so return this particular update state. So again, returning the updated state. Cool. Now the grader node. This is the grader node. What the grader node will do is, the grader node will filter out the non-relevant documents from the state. It will filter out the non-relevant documents from the state. We know what the grader does for us, right? Okay, we'll see it. So it takes in out again input the current graph state and output an updated state with filtered relev document. So what it does is, it updates this documents key by replacing. So we know that whenever the retriever node runs, it gets all the documents that it found by running a similarity search over the vector store. What the grader node does is, say that it got let me write a bit over here. Say that the retriever node got A, B, C, D, 4 documents, okay, by running a vector similarity search on the vector store. Now what the grader node does is, it uses that particular LLM grader which we defined, which provides a binary output yes or no. If the document is relevant to the question, then it responds with yes. If that particular document is irrelevant, then it responds with a no. Based on that logic, we will filter out the irrelevant documents from all the fetched documents. So say that out of these 4 A, B, C, D 4 documents that it retrieved, say that A and B are irrelevant. So what the grader node will do is that it will filter out A and B and update the documents key in our state to have just these 2 documents, and it will kind of update the documents thing. So I should also write it here. This is the documents key in our state. Okay, so it used to be this after retriever node, but after grader node, it will filter out all of the irrelevant documents. Now what happens if none of the documents are irrelevant? Yes, it will filter out everything. Okay, what happens if all the documents are okay? Let me kind of reiterate on this. I think I made a mistake. What if all the documents are relevant? Well, then it won't filter out anything. What if all the documents are irrelevant? Well, in that case, we will have to define an if-else statement. If all the documents are irrelevant, then we have to go in this path. We have a fallback strategy for that. We will rewrite the question that the user provided and again go for retrieval. Okay, so checking document relevance. Again, we fetch the question and documents. So you see, our state might contain multiple keys, but in a particular node, if we require the information from just 2 keys, we will only fetch those. We don't need to fetch any information that we don't require, that we won't be working with in this particular node. Now using the grader chain to grade every retrieved document, I have defined the grader chain in the last video. And then documents for which grader chain responds with yes is appended to filtered documents. So I've created this list filtered documents that will only contain the relevant documents. Then I'm using a for loop to iterate through the documents retrieved. I should write it here, iterating through the retrieved docs. For d in docs, grader.chain invoke. So whenever we invoke the grader chain, it will respond with a yes if the document is relevant, no if the document is irrelevant, and then we get a grade for that score, or the binary score will simply be a yes or a no. Now if the grade is yes, document relevant, and we will append that particular document to the filtered documents list. Else it means the document is irrelevant, and we will ignore that. We won't basically be doing anything with it. Okay, return documents, filter documents, question. Okay, cool. Okay, now you might be thinking, where is that step in this where we are going to rewrite? Well, that will be defined in a tools condition, that will be defined in a conditional edge, my bad. Okay, we will have a conditional edge in place to look out for that condition where there are no relevant documents to fall back on. Okay. Now we are defining the rewriter node. The rewriter node will again be using the rewriter chain which we defined. Pretty shabby, pretty basic, just the current graph state, taking the question and the documents, and then yeah, we didn't need documents to be fetched over here, but yeah, I just did it. Okay, I didn't need that. Now the new query will be what the question rewriter writes. If you don't know what the question rewriter chain looks like, I mean, check out the first video. Yeah, so return the updated, so I would just say return the updated state with the rewritten question. Okay, all right, running it. So up until now we have defined the retriever node, the grader node, the rewriter node, now, and also the LLM node. Yeah, now we need to define these conditions and all. Okay, these are called conditional edges in LangGraph, you know that, so we will be defining them right now. Now defining the graph conditional edges, defining the conditional edges that checks. So first is the relevance check, and the relevance check is basically this thing. Okay, so this is called as this right here, we are calling it as let's keep it yellow, right? I mean, yeah, I mean, let's have some kind of professionalism, guys, come on. Yeah, I'm calling this as relevance check. Okay, so I'm defining relevance check. It decides whether to go response generation node, this node, the response generation node, or rewrite the query for a better response. So I have created the logic for this conditional edge. You might want to change it if you want to achieve something which you desire for. All right, so print, I'm printing assessing graded documents, fetching the question. Well, I don't need to fetch the questions for this, that's why it's showing a yellow marker. I might even want to delete this part because I don't need this conditional edge to have the question. I mean, it's not processing the question in any way. Okay, so you see how it works, how LangGraph works. I mean, you only fetch those keys from the state which you want to work with. I'm fetching the filtered documents, and if filtered documents list, filtered docs list is empty, well, that would mean that there are no relevant documents. In that case, I would say no relevant documents was retrieved, redirecting for query translation. This is also called as query translation. I told you about this last video. Rewriting the user question in different ways is called a query translation, and it's a separate topic. If you want to learn more about it, just write it in the comments. I know about it and I am ready to share that knowledge with you guys. Cool. Yeah, so if the filter docs list is empty, then I want it to go to the question rewriter node, this node. Else, if there are some documents in the filter docs list, I mean, we have some relevant documents to work with, go towards generate. Now you might want to say that you might want to create a logic such that if we have at least 2 relevant documents, go to generate. If we have at least 3 relevant documents, go to generate. You might want to do that. There's nothing wrong with that. Okay, but I'm keeping it simple. If there are any relevant documents in the filter docs list, go with the generation, no problemo. Now, yeah, now I'm defining this particular conditional edge. I'm calling it as the hallucination check. why I named it like that. Okay, I'm calling it hallucinations check. Okay, so basically what it will do is, you know that we created a hallucination grader chain in the last video, this particular one, this bad boy, and it responds with a yes if there are no hallucinations, and it responds with a no if there are hallucinations. So if there are hallucinations in our LLM response, if there are hallucinations, we want to regenerate that response until and unless there are no hallucinations. And if there are no hallucinations, then go towards this particular thing. Now I'll show you a simple thing. I did not create this conditional edge separately. I have integrated this conditional edge in hallucinations check. I'll show you how. Now for this, we fetched the info required from the current state. So we fetched everything, okay, the document response, question, everything, because we require this. And then we got the score from the hallucination grader, and this is the grade. If the grade is yes, it means that there are no hallucinations. Then go towards answer grader. I'm calling this as answer grader. Answer grader. Okay. So if there are no hallucinations, go towards answer grader. Pretty easy. Okay. Now I am kind of integrating the answer grader part in the hallucinations check conditional edge itself, because conditional edge is basically an if else statement, right? And we can have nested if else statements, you know that, right? So I just did that. No hallucinations, proceeding to answer grader. Score is equal to answer grader that invoke the question and the response. Answer grader is basically trying to assess whether the answer that the LLM generated is helpful or instrumental to answering the question which user asked or not. Now if yes, if the answer is useful, then I'm saying print instrumental answer and return to useful. Now what is useful? What is the useful node? We haven't defined that yet, right? I'll show you what I do with this. Okay, I'm trying to showcase another functionality of LangGraph with this cheesy trick. Now else, if the answer is not useful, return answer not valid, return not useful, return to this particular node. Now what I will do is I will map useful to another node which basically prints the answer, and not useful to the rewriter node, so that it can again go through this workflow. Else, if the hallucinations are there in our answer, then print hallucinations found and return to not supported. Now if hallucinations are found, then not supported, I want to map this string not supported to the generation node. So this means that while working with conditional edge, we might not use the exact node names while returning from the if else statements. We can map them later as well while defining the builder object. And then I defined another simple node for answer printing. This node is doing nothing. It's kind of this node. Okay. Oh wait, what did I do with this, man? It looks pretty weird to me. Yeah, this is the node. Answer generation. The answer output node is just taking in the response and printing it. Okay, cool. Now I'm building the graph using the fragments. We created the node, the conditional edges and everything. Builder object instantiation, I can go pretty quickly through this because it's pretty basic. If you have run through the agentic workflows playlist, we used to do this every single video. Builder add node, retrieve the grade documents, retrieve, just a second. Yeah. The retrieve node, the grade documents node, the generate node, the question rewriter node, this one rewriter node, and then the answer output node, which is this node. I haven't signified it as a node over here, but I created this for what do we call that? quality of life improvement. Okay, if you don't create this, there's no problem with that. I just created it so that we can look at the response in a better way. Now defining the edges, start to retrieve, because this is where it's starting, then retrieve to grade documents node. Cool, this particular edge. Now we have a conditional edge, not additional edge. We have a conditional edge over here starting at grade documents, and then this is the relevance check, where it might want to bounce the workflow to generation node as well as to rewriter node based on the filter documents list. Yeah, so done. Then again we add an edge from question rewriter to retrieve node. So this is the kind of feedback edge that we have over here, which might be used in case we want to fall back to rewriting the query, the user question. Then we have another additional edge, conditional edge, called hallucination check, which is going from generation node to hallucination check. Now what I was talking about is written over here. Now in hallucination check, we were returning useful, not supported, which are not names of nodes, but those are kind of simple colloquial terms that we were using. And now we can map those words to some nodes that are present in our graph, so that it can kind of control the workflow to streamline the response generation. Okay, so you can call this as, I can simply write it here, mapping the outputs to the required nodes. Okay, so it means that whenever the hallucination check function returns not supported, it means it will go to the generate node. Useful will go to answer output node. Not useful will go to question rewriter node. Okay, you might want to play around with this logic, see it for yourself. You can't learn swimming by watching YouTube videos of swimming, right? Okay. Now the final one, answer output node, which I created to end. Okay, so this is where it ends. So whenever the answer is generated, we end the graph. Pretty basic. Okay, now we are compiling the graph that builder.compile, donezo. Now let's see if it's working or not. So here I kind of have pre-written a question, because the PDF with which we are working is pretty easy. Is a McKinsey report on Europe's stance on generative AI, or what's happening in Europe related to generative AI, all those stuff. So this is a question which is related to that. Which country in Europe has a leading position in AI semiconductor equipment manufacturing? And this is a question to which we know the answer. It's Netherlands. Okay, now invoking the graph to get the output. Let's see. So went to the retrieval, checking document relevance. It found the first document as irrelevant, then a relevant document. So out of the 4 documents that the retriever node retrieved, 3 were irrelevant. So yeah, that's it. But 1 was relevant, so we are moving ahead with the response generation. Assessing graded documents, relevant documents found. So moving ahead with the response generation, generating response, checking for hallucinations. No hallucinations, pretty good. Proceeding to answer grader. It's an instrumental answer, and the response that we get is Netherlands has a leading position in AI semiconductor manufacturing. Cool. I mean, this is what we wanted, right? We are kind of controlling the flow in a better way, and this is improved RAG for you guys. I mean, this is much better than the naive RAG, which did not have any fallback strategy. What if no irrelevant documents are retrieved? What if there are hallucinations? All those stuff are being remedied over here. This is adaptive RAG adaptive RAG manifest. Okay, cool. Now we have kind of created this workflow. Now it's a time to stitch them together, and the component which will be stitching them together is the router component. So I'll write here stitching. What I forgot the spelling of stitching, guys. Stitching together the graph and the chain that we created. Okay, now we define an app. I call it app for, just like that. It's just a function. It takes an input string and it generates a dictionary out of that, and then it runs a router chain on it. So we know that if the router chain can provide two responses, vector store or web search tool, something like that. If the response is, and then we get the path which has been chosen by the router chain. If path is vector store, route it to vector store, and we invoke the graph, this particular graph. But if the path is web search tool, I have written just else over here, because we know that if you go to router chain, you can see that we have it can only respond in two literal terms, vector store or web tool, something like that. Okay, else go to web tool, and we know that our web tool is an LLM binded with tools, so it can also handle generic LLM responses. So Gucci. Let's kind of create this now. Let's run this. Hi, what's up? Now this, our application, our adaptive RAG application, you see, has a lot of powers now, It can handle a diverse range of user queries, which we were talking about in the beginning. So if we ask it, hi, what's up? It will not go to retriever node. It will not retrieve anything from this. It will just respond with, hello, I'm here to help you with any questions or tasks you have, blah, blah, blah. It can also answer some generic terms, some generic things from the web, like, again, what is the capital of England? Now it routed to the web tool, calling Pavelli tool. And the answer is London is the capital of England. It is providing a big answer. You can cut that short by prompt engineering, we know that. And it can also answer questions from our vector store. Where is that question? Man, I didn't really read that document which I've ingested. That's why I have to copy the question all the time, man. Like, seriously. Yeah. Let's run it. Now it has routed to the vector store, retrieving, checking document relevance, and all those stuff are happening. And we have the answer from our vector store. So it is definitely handling a diverse range of user queries, and it is also handling a diverse range of data sources, I would say. It is also handling irrelevant retrieval problem. It is also handling hallucinations. It also has a fallback strategy. Whenever there are hallucinations, it has a fallback strategy. Whenever there are no relevant documents, it has a fallback strategy. All right. So this is it, guys. You see how it's working, and this is the workflow. I know that I've done it in a notebook because I want a lot of people, who are beginners with Python and all, who are working with notebooks, or data scientists who like to work with notebooks and are stepping into this field, just like me. They like working with notebooks for prototyping, right? That's why I've created this in notebook. But in the future, I plan to create a simple, like an application out of it, where everything will be in a script. And what you want to do is that you want to place all the different chains in different files, so that you have your code modularized, and you can also improve your prompts and everything. Now, one interesting thing, let me check if I was logging all of this into my LangSmith. Let's see what's happening over there. Run. So I have this particular project over here, PR will that straight. It's kind of a weird name. Yeah, let's see what's happening under the hood with LangSmith. So this is the chain which we, this is the LangGraph which we ran right now. What it's doing is, it started with which country in Europe has a leading. This was our question, right? It went to retrieve, and you can see all of these 4 documents are retrieved. You can also click on them to check them out. Okay, and then after retrieval, we are grading them. Let me go to the grade node. Yeah, this is the grading them. Now after grading, before grading these were the inputs. After grading, it only has provided us with one relevant document, which is this, and you can easily see that it is kind of, it consists of the information which we want. That is Netherlands based ASML is the market leader, which is basically trying to provide for the response that we want. Then we have this workflow running in, which took in just a second, right. My internet is lagging like stupid, guys. I mean, come on. Then we get all of these things. I mean, yeah. Then this is the question and this is the document that we have, and we feed all of that to the, just a second, man. Why is my, yeah. Then we put all of that to relevance check, and the answer is I mean to hallucination check probably. Where are we currently? Yeah, we are over there. Yeah, right. Then you can see that we got the response as no, and then again we went to a runnable sequence, and then this is the hallucination check basically, and we got a response as yes, and then blah 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 blah. So you see, this was a pretty complicated workflow, and the final answer that we got was just a second, the output channel right in wait runnable sequence. So this is the hallucination check, and then there is the answer output. Yeah, this is the response that we got. So you can see that you can also use LangSmith tracing to check out the entire workflow, and you can play around with it and build on top of it. Yeah, pretty cool. In the future I'll be trying to develop more of these kind of intuitive applications. Now that I've empowered you guys with LangGraph, we can do a lot of shit, you know, we can just have fun. So thanks a lot for watching this video, and feel free to comment on anything that you want to learn. I'm all in. I am all in. Okay, so bye bye, thanks for watching, and see you later.